Cast is now starting. All attendees are in listen-only mode.
Good afternoon, everybody, and welcome to today's webinar, Replacing Design Assumptions with Facts. My name is Rob Romanowski, and I am the Director of Sales Operations for 3HTI. And with me today, our special guest is Mr. Andrew Leedy, who is an applications engineer with PTC. So what we're going to talk about today, and what Andrew's going to show to you, is something called the Creo Product Insight Extension. And what this does is it works on top of Creo, utilizing sensors which will allow you to collect real-world product data from either a prototype or a real working product or part, and then you can bring that data back into your CAD design. And overall, the goal is to help you improve your product designs and collect information. And because this is fully integrated with ThingWorx, and ThingWorx is actually the world's leading industrial IoT platform, it makes it super simple to collect the information and share this data. So I'm very excited to have Andrew on and see his presentation as well. So real quick, if you're new to 3HTI and you're not really familiar with who we are, I know that we have a lot of people who are familiar with us from seeing the registration list. But we're a systems integrator with a focus of helping discrete manufacturing companies in all phases of product development, from design through manufacturing. And what we really want to help companies focus on today is their initiatives with Industry 4.0 and digital transformation. And digital transformation can mean different things to different companies, but in general, it's being able to take product data information and share it throughout the enterprise easily and quickly get from where you are today to where you want to be. And this the Creo Product Insight Extension helps you to do that. This will help you with your digital transformation process. And that's a very condensed and short version, and there's a lot more detail to it, but we're not going to get into that right now. We could talk more about that some other time. But also with taking those, the idea of taking concepts and ideas and transforming them into a digital file that can be used for augmented reality, 3D printing analysis, and other ways that a part or assembly is shared inside and outside the enterprise, we offer a whole host of other solutions, whether it's 3D printers from Markforged and EnvisionTech, which print in metal as well as various composite materials. And with EnvisionTech, they provide parts with the highest resolution in the industry. We also provide analysis solutions from PTC, as well as a host of offerings from Mentor Graphics. And also there are design optimization tools available from Solid Thinking, and a host of other solutions as well for machining from NC Simul and Multi-DNC. So what I'm going to do now is give the controls to Andrew, and we will get started.
Okay, thanks, Rob.
You're welcome. Thank you.
Just give me 1 second to share my monitor here, and please let me know when you can see that.
I see it.
See Creo Product Insight?
I do.
Okay, perfect. So we can get started then. So thanks for that introduction, Rob. As he said, my name is Andrew Leedy. I'm an application engineer here with PTC, and I'll be the one leading us through this quick demonstration of Creo Product Insight and give you an idea of what that extension is all about within Creo. So the short of it is Creo Product Insight allows us to take advantage of the IoT or Internet of Things and replace our design assumptions with facts. Now, before I actually get into the capabilities of the software, I'd really like to just take a step back, talk about some of the challenges that we're hearing from our customers and that you might be hearing or that you might be experiencing yourself, and really why Creo Product Insight was designed. So the first one is, well, we design our products based off of assumptions. How big is this? How hot? How fast is this going? And a problem really occurs whenever we're trying to discuss if these are really good assumptions. They may be good, they may be bad, they may be incorrect, but we don't really know until we build the product or make a prototype. And so we go forward and we start testing things. So we attach sensors, measure, record everything that's going to be important for our design. We do all this to make sure that we're doing the right thing. And this is the real world. How do we use that information to get and make better designs, whether this is going to be for a current product or the next generation of products. How do we make use of all that different sensor information, all the different testing we're doing out in the field to make sure that we're designing the product right the first time, or at least making it better whenever we go look at it that second time after we've done some intense testing. So that's what Creo Product Insight is all about. It's bridging the gap between the theoretical and the real world, tackling that challenge of how do we make use of the real world data we're collecting about our products. Now, this is an add-on extension to Creo Parametric that provides the specialized tools to design for connectivity. It's all about getting us better connected to those real world objects. And it does this by using sensors to capture all the relevant data and return real world data from physical products. So having a two-way conversation between the physical and digital world. And it does all this to replace assumptions with facts, gain a better understanding of how our product is going to operate. Because it's hard to design and simulate if we don't have a full understanding of what this piece is going to go through or what this product is going to go through in the real world. And it further than this, it uses Creo Parametric to optimize, improve, and respond. So we might know the true loads, the true thermal pieces come from this part. So let's design the part around that to get the best possible design and not have to go through 3, 4, 5 iterations of that product to get to something that actually is going to work and we want to produce and put out in manufacturing. It allows us to, within actually how it works within Creo, is allows us to easily define and place these physical measure sensors to Creo assemblies. So it puts these sensors in as fully fledged Creo parts, or just as simple blocks or circles, or even just a point on a screen. But what's really important about these sensors that we're applying into our Creo assemblies are that they have attributes, and we can use these to give our designs a little bit more intelligence. And I'll go into this a little bit more in our demonstration. It also comes with this idea of this new instrumented assembly. This isn't something that's mandatory, but it's really used to protect our existing designs. This is an alternative to bringing in your existing top-level assembly. So you can have this instrumented assembly, which is an inherited model, if you guys are familiar with any of our other extensions that use inherited models. But basically, it uses a one-way associativity. So any changes I make to this model, they aren't reflected on that top level. They're not going to be included in my bill of materials that I'm pushing to manufacturing. It's just going to be used to do all this testing and to better run my simulations. One more slide here before we go on. It has a seamless connection to sensor data from a file, so we can do a kind of an offline mode of getting the data into Creo. So we don't have to be linked up to ThingWorx or the Internet of Things, but it really works better if we can have that real-time data being fed in. But if we don't have that, we still can pull in some of this from a spreadsheet format and apply different sensor information into our models. But really, it does offer a seamless connection to sensor data from ThingWorx, and that's the main point of all this, I think, is to link our real-world sensors and feed this data into Creo directly without having to do an import every single time I get a new data set. Okay, so now with that quick introduction into Creo Product Insight, I'd like to go into an actual demonstration of this and show how it actually works in action. So let me just bring this up. So for this presentation of Creo Product Insight, we're going to be designing a throttle body. Now, it's a pretty straightforward design, cylindrical opening with a disc in the middle that's going to open and close, and it's going to change the fluid flow or the airflow that's actually going through this. It's going to be able to change the speed on this to actually throttle that. So I've designed everything exactly the size I need so everything flows properly, but is this the same as the real world? Did I make this design with the right assumptions in regards to what kind of load it's going to be placed under? So traditionally, I could take a step to apply some of these loads that I think it's going to encounter for whatever I think is going to happen. So test it, maybe see what it works. We're applying a thermal load on the back because we have a high temperature coming from our flow. But let's take another step beyond this with Creo Insight. So with Creo Product Insight, we can place sensors into my CAD model that are going to receive data from the real world. Now, these sensors could be prototypes of actual products. They could be just points on the screen, as I'd said, or they could just be very simple CAD models. But the main thing is I want to know that this is going to work in the real world. So I want this particular sensor to have some extra intelligence added into it. So let's take a look and see how this is actually going to work, how we can apply and manipulate these sensors to actually give us a little bit more control of our design. So as I said, we have a few of these different sensor models that we're going to bring in here. In this case, we're just going to bring in a standard rotary sensor for this. And this CAD model is just going to be a disk. As I said, it doesn't have to be a fully fledged model. It could just be something very simple. What's important about this are that it's a sensor, so we're going to apply some sort of data to it. So we have an XML document that's going to control this angle parameter. So this is what I want this sensor to actually measure. I want it to measure an angle within my particular CAD model. So we could bring that in, hook that into my actual my Creo part, and now it has a parameter, and it's a special kind of parameter. It's a sensor parameter. So it's not just any kind of normal parameter that we're pushing to Windchill or to our PLM system. It's adding in an extra layer of intelligence. So now when I go through the model is much more than just a standard Creo part. Now we're going to attach it the same way we would any other Creo part, maybe link up a coordinate system, but there's an extra little bit here for this sensor. And we can take that angle parameter that we took from that XML document, and I could link it into an actual part of my model. In this case, there's a dimension that's on my throttle body that's describing that disk, the angle of that disk. So I can go through and link that angle to define exactly what the angle of that disk is going to be located at. We have a simple note that's showing what that sensor A is currently at. So we currently have it at 50 degrees, and I can simulate this getting a real world value by just going through and changing this pretty simply. But we're going to go through and actually do this in a little more automated process in just a little bit. But that's how we can actually have just a sensor CAD model drive a change within our assembly. And this is going to be very important going forward with this demonstration. Now, something else we might also be concerned about or maybe finalize, this side if my model is actually going to work, there's a clearance value that we care about. So when the temperature changes, the size of this disk and the size of my whole model might change under the stress that that's going to induce. So I want to set up an analysis feature that we're going to call clearance that is always going to be looking and measuring this particular point in the model. And I'm going to look at that later on to use that as my validation for my design. Is my design going to work based off of that clearance value? Because obviously if the clearance is exceeded, there's going to be a problem with my value. I'm not going to be able to swing that disk anymore inside, and we're going to have a failure in my part. Now, to be able to validate this and check this a little bit forward, we're going to need a little more information. So we're going to put in a temperature sensor. So same thing as before, we can constrain to the model wherever it needs to be. As just as before, this is a very simple model. It's just a block that we're going to place in. And the same as we did before, we're going to link it to a parameter, or we're going to create a link again. And this time, instead of creating a link to a dimension, we're going to create a link to a parameter. And this parameter is going to be driving our Creo Simulate load. So we already have a load value that we're applying into our simulation. And basically our parameters can just be moved very easily between all the different Creo extensions. So we're going to have this sensor this time drive that parameter instead of an actual dimension that's going to be on our screen, something we can select. It's more of a value that's going to be changed based off of our simulation runs. So instead of me typing in a number, we can actually also load in some real world temperatures. Now, if you remember in the PowerPoint I went over, we can also not only link directly up to the Internet of Things and bring in real life sensor data, I can also load data in a more manual way. So here we can just load in a file that's going to be on the PC. We have a CSV file that we're going to bring in. Basically, this could be maybe something that's coming from Excel. We have some documented instances of what my sensors are reading and what the corresponding angle measurements were for those particular sensors. So this is going to be useful to be able to push forward with my design. Now let's turn to ThingWorx. So I'm not going to go do a full-fledged demonstration of what ThingWorx is. I only want to show the integration with Creo, with Product Insight. But ThingWorx in general, if you haven't heard of it before, is PTC's platform for enabling the rapid deployment and development of solutions for the Internet of Things. So it's our product around harnessing the Internet of Things. And in this case, we're going to use it to push forward and help our Creo designs. Now within ThingWorx, again, I'm not going to go fully into everything we're seeing on the screen here, but what I want to show you is that we don't have any models set up right now, so that we have not created our link to Creo Parametric yet. So we're going to do that right now. We can go back to Creo, publish off some of our sensor data. So we want to see exactly what models and sensors we're using within Creo Parametric, and then we're going to show what we're going to link to the real world from those CAD models. We're going to create that link and have it also kick off an event. So anytime my real world models or my real world values change, it's going to tell my Creo model that we have a change to push forward to. So now we've created a link here. We can go to my analysis events. We can start a new one. So we can pick what events we want to keep track of as a source and which model we want to link to. So we have a ThingWorx object which is our demo instrumented product that actually has some sensor data on it. And anytime there's a data change there, I want to kick off an event. And it's gonna talk to that model name, my Creo model, my instrumented throttle, and it's gonna communicate and do something whenever we kick off that event. And then we're gonna go through and set up what it's actually gonna communicate, so we can go through and map our data. So this is where we create a direct link and a relationship to our Creo data. So on the left, we have some temperatures and angle and name measurements that are properties within ThingWorks. And I wanna say what the corresponding Creo sensor was. So we have that temperature sensor that we had originally. I want that to be linked up to the temperature parameter in ThingWorks. I want to go to the angle sensor within Creo Parametric. So again, that's just creating our relationship. Now within Creo Parametric, we're going to connect to that server, and it's pretty easy to do. There's a pretty seamless integration into ThingWorks from within Creo. And the idea is that we're going to tie into various maybe test cases or machines out in the field that we want to link up to and get data from. Now, as soon as we send some of that data into Creo Parametric, it's going to warn us that we have a notice of new sensor data coming in from ThingWorks. And we can go through, decide if we actually want to push this data forward or not, which if we want to do some testing and validation, we definitely want to do. Maybe view that data first before we apply it. Maybe we only want to select from a few of these as well. We don't have to run all, but we can also check off and just run a few of them if we're only concerned about a certain maybe temperature range or angle range that we're going to be looking at for today's simulations. But we'll just load everything in just for the sake of it. This is going to move our model around and apply some of our temperature loads. So now we have that information tied in. Let's go into Creo Simulate. So if you haven't seen Creo Simulate before, basically Creo Simulate is our integrated simulation software. So this is going to allow us to take all that different good sensor data that we loaded in from ThingWorks, put it onto our model, run some different simulations, have a lot of that done automatically for us, and eventually be able to decide if our model is going to hold up under certain temperature and angle measurements that we are applying. So I'm not going to go into a full-fledged demonstration of Simulate, but we do have some boundary conditions and loads already set up here. And the one thing we do want to change that we do want to set up is the load that we're applying is that temp load, a load that we originally linked into our sensor T, so our temperature sensor. So as that sensor T is going to change, it's going to change that temp load value and push in a new value for that load condition that's going to run our simulation here. And we can see exactly how this was placed, maybe go through and modify it if we need to. But for the sake of this, everything is already set up for us. So we'll just apply it. And it's already telling us that we're at 110C. That's currently what it's being used for. But that's going to change and be modified depending on our data set. So we can run an existing test that we've already set up. We've already gone through and chose what boundary conditions and loads we want to apply. And once that's done, we can just go see our results, see what happens to our model with this particular load. So now we can go through, check our results, verify that our design is okay. We're just doing some standard Creo Simulate work, just with a little bit more intelligence and having the actual value of our test being driven from somewhere else other than just me putting in a static number or assumption. We're using a real number that was recorded out in the field to do all this testing. Again, this is just some standard Creo Simulate work to be able to go through and actually view this and decide if this is going to be good for our design or not. We also might want to check our structural node, because anytime we have a change in our thermal, that's going to apply some kind of load that's going to maybe morph the structural integrity of our particular model. So we have our thermal analysis already loaded in here. And we see, okay, we're using that standard thermal analysis that we had. In addition to using that analysis for our structural load, we also have some measurements that we're going to be concerned about. So we have a vertical displacement on my top and the vertical displacement on my bottom. And this is going to help me go through and check that clearance that we were concerned about at the beginning, making sure that after we run the simulation, we have some new measurements for our clearance, and we can verify that that's actually, less than what our clearance was before and doesn't exceed the clearance, and we don't have a model conflict and it's not running into the edge of our model here. So just some standard Creo work. So back out of Simulate, we are setting up an analysis feature. So specifically, we're going to make this our structural and thermal analysis that we're using. And basically, what we did before was we just ran one case of that. We had that 110 measurement from our sensor, temperature sensor. We ran one case, but what about all those other cases we brought in? Well, we want to set up another analysis to just start kicking off and running through all those different use cases. And from that test, what are we mainly concerned about? maybe we're concerned about the stress, we're concerned about the maximum displacement, but really in particular, what we had set up before are I specifically care about that vertical displacement on the top and the vertical displacement on that bottom. So that's what's bringing in from our simulated analysis, and I want that to be a part of our model, and I want to be able to check those results and verify that my test is working. So we're going to do one last analysis, and as I said, we always want to go through and check that those results are that they're satisfactory. Instead of me just visibly going through and checking them and doing math every single time, we can set up one more analysis that's going to create a relation for us. It's just going to give me a simple yes, does my design work, or no, it does not work, that there's an interference and that we need to go through and make a modification to this part or make a modification to the environment that it's going to be running in. Now, if we want an easy way to display and track these results, we can also put in an additional sensor. So the sensors don't have to be directly reading in data from out in the world. They can actually be used to set up this relation that we're going to be doing here. So I want these sensors to give me the important values that we're talking about, those ones that I want to check. In this case, this model doesn't even have a geometry, it's just a point on the screen. So as we did before, I want to map some of these values, map the different parameters I'm using, but we want to use our design clearance compared against the real world clearance that we are simulating through our model. So grab the first analysis we started with. We'll just go through, do our homework here, make sure that we go to our structural and thermal analysis that we set up. We have that vertical displacement that we want to bring in. We can insert that. We also, from that same analysis, we have that bottom displacement. So we're going to be using that to compare as well. So we have a parameter, going to find that feature that we were looking for, specifically in that structural and thermal analysis that we ran. Run through, grab that vertical displacement on the bottom. And then finally, we want to see what our issue is, our yes or no answer that we set up. This is going to be another parameter that we're putting in, and this is going to be that last analysis that we set up, that relation that just ran through, did a simple equation to subtract the two numbers and see, well, if this number's higher than this number, spit out that yes, this works. If it's lower, spit out that no, it doesn't work. So now this sensor is reading in just all that information, just basically summarized for me. So my sensor C, what's my result? What are the two different measurements? And do we have an issue, false or true? So this is going to give me that final answer. Do I have an issue with my interference? So what we can do from here to make sure that this always works, because we have one case that it might work in, we want to run through all that different data that we brought in. So we did all the setup here. Now we're just going to run through, maybe pick from a few of these or pick from all of them to make sure that this always is going to work. It's going to run that simulation and check every single result for us. We could see specifically what those sensor C readings were. We got a no for one of the things that we brought in, but at the bottom here, we also have a yes, that we did have an interference issue. So this is telling me that at that certain temperature range, 130 and 0 degrees for my angle, there was a problem with my model and it could not figure out that the clearance was too much. So what we did here is we designed our model, brought some real live sensor data in, did some standard work within Creo to run some simulations, but we did this to run through a bunch of different use cases for this particular model, and I could go further and run it for every single thing to just get a better idea of how this is going to work in the real world, and just let me design my part a little bit better. So now, just to summarize everything that we talked about today, just like to skip all the way to the end here. I just want to just summarize what we went over. So one, Creo Product Insight Extension allows us to validate our design requirements by replacing those assumptions that we're typically using with real world data. So it allows us to make the very best possible designs. It also ensures that new product designs are going to provide the necessary data stream. So we want to be connected because this allows us to make good, educated decisions. If I'm unconnected from the real world, I don't really know how this is going to work in the real world, then how can I possibly make a good design? I'm just going through blind. Lastly, I want to improve the quality of my current and next generation products by identifying those and correcting those design flaws. So where do we have room for improvement? What did I do wrong the first time and what can I do better the next time? And really just identify business opportunities for new products, features, or product extensions. So go further with our designs by staying connected. So that is Creo Product Insight. So thank you for attending this demonstration. And I think we have a little bit of time for a Q&A if anyone has any questions. think you can just
Absolutely.
type it into the box there.
Yeah, just type your questions into the dashboard, and we will get those answered for you. Question that I have, Andrew.
Sure.
Are you aware of some, or can you name some of the companies that are currently using this extension?
I don't know specifically what I'm able to talk about with that.
Hmm.
So I don't think we can, but maybe if maybe we can get some of that information over to you that we can share out. I'm not sure exactly what we're allowed to share.
Gotcha. From a past conversation I had with somebody at PTC, I know that Procter & Gamble's one of the companies that's using this. So anyway, I think we did a really good job because there are no questions in the queue.
All right.
So what I'm going to do is I'm going to show everybody. I'm going to take control. This will do it. All right. So just to wrap up today, I want to thank everybody for being on the webinar. And if you need any additional information or have any questions, please give us a call toll free at 3HTI 866-624-3HTI, or you could send us an email at info@3hti.com, and my personal contact information is also on the screen in case you want to contact us. So I will send everybody a recording of this webinar either later today or first thing on Monday. Once again, I want to thank our audience for being on today, and thank Andrew Leedy for leading us in the presentation. We are dismissed. Thank you, everybody, and have a great weekend.
Have a good one. See ya.